So today we are studying. We are learn about the forced vibration. Okay. So forced vibration. What is forced vibration? So we are already study about the learn about the simple harmonic oscillation and the damped oscillation. So simple harmonic oscillation is a identical case. There is a no external influence, there is a no external frictional force or happen. So this is the identical case, and in the natural case this is a not identical case, or a natural case. There is when the body is moving along with some direction, obviously there is some frictional force happen. That's why the amplitude of the body is continuously decreases with respect to time. When you need to a standard wave, then you need when suppose this is a simple harmonic oscillation. Okay, this is the damped oscillation. We already learned about that. So in these natural cases, if you need such type of simple harmonic oscillation, you must have to resist this decreasing of the amplitude of this damped oscillation. Then you need some external force to continuously increasing the amplitude of this oscillation. Then you get the such type of simple harmonic oscillation by through a external influence force. Then you get a damped oscillation to a simple a standard case like that, and such type of oscillation is known as force oscillation. So that means, so suppose so now we try to set a equation for the force oscillation. So obviously force, obviously you put some force along with the body. Obviously the resistive force is proportional to minus x, because if the direction is along the x axis, so F is equal to minus mu x. Mu is equal to proportionality constant in the first case. In the second case, so obviously force is also proportional to minus dx dt is coming from the damped part. So obviously m is equal to minus r into dx dt. R is also proportionality constant. Clear? And third one is the external impressed periodic force is F0 cos Pt. This is a periodic external impressed periodic force, because you need to resist this damp oscillation from a like a standard simple harmonic motion case. Then you get a motion, and this motion is known as force oscillation, because you put some external force for the resist the decrement of the amplitude of this damped oscillation. Then you get the force oscillation. And so, is it clear? Then if you set the equation, then m d2x dt2 is equal to f0 cos pt minus mu x minus r dx dt. Is it clear? this is the initial force, this is the resistive force, this is coming from the damped part, and this is the force, external impressed force you given to resist the decrement of the amplitude of the damped vibration. Then you get the vibration, and that type of vibration is known as force vibration. Is it clear? d2x dt2 plus r by m dx dt plus mu by m x is equal to f0 by m cos pt. Clear? Let 2b is equal to r by m. This is, we are choosing that because of a solution of this equation. Omega square is equal to mu by m, and small f is equal to f0 by m. Clear? It is clear for everyone? Clear. So the equation is become d2x dt2 plus 2b dx dt plus omega square x is equal to f cos pt. Again, like the damped oscillation, let d by dt is equal to d, then d2 plus 2bd plus omega square x is equal to f cos pt. Is it clear? So from this we get x is equal to f cos pt by d2 plus 2bd plus omega square, or x is equal to f cos pt. Now we try to find out the solution of this equation. Okay, of this equation, omega square minus p square just a minute. Omega square plus d square, omega square plus d square plus 2b d f cos pt. Cos pt by omega square minus p square plus 2bd x is equal to omega square minus p square minus 2bd f cos pt divided by omega square minus p square plus 2bd omega square minus p square minus 2bd, or x is equal to omega square minus p square minus 2bd f cos pt divided by omega square minus p square, that whole square, minus 4b square d square, that 4p square d p square d square. Okay, just a minute. B d square. Okay, then x is equal to omega square minus p square f cos pt divided by two part, omega square minus p square whole square plus 4b square p square minus 2b df cos pt whole divided by omega square minus p square whole square plus 4b square d square. Well, p square d square. Another thing is that putting the sorry. Another thing is that putting the d square is equal to p square. How I could get this equation from this? Because we have already hence let the solution, we have already chosen a solution y is equal to a cos pt plus minus alpha, because the resultant frequency of the wave is dependent on the this frequency, the external impulse frequency of the force vibration. So this one, so obviously d2y dt2 is equal to s square cos pt a square p square cos pt plus omega minus, so sorry, the minus p square a cos pt plus alpha. So obviously it is become minus p square is equal to y. So d square y is equal to minus p square y, also obviously d square almost equivalent to the minus p square. That's why I put this here, d square is equal to p square. Okay. Now we try to find out the solution. Already taken here from we get the substitute from here to here. Now let another choosement r dash cos alpha is equal to f omega square minus p square by this part we have chosen omega square minus p square whole square plus 4b square p square. Clear? And r dash sine alpha is equal to 2bfp by omega square minus p square, that whole square is equal to 4b square p square. Is it clear? Then r dash square sine square alpha, r dash square plus sine square alpha plus r dash square cos square alpha is equal to, we get f square omega square minus p square, that whole square omega square minus p square, that whole square plus 4b square p square plus 4b square p square f square omega square minus p square whole square plus 4b square p square, 4b square p square. So r dash square obviously is become 1, sine square alpha plus cos square alpha is equal to f, if you put omega square minus p square, just adding these two part of the equation, then you get plus 4b square p square omega square minus p square, that whole square plus 4b square p square, that whole square. So one part is cancelled out. Then r dash square is equal to f square by omega square minus p square, that whole square plus 4b square p square. So obviously r dash is equal to f by root under omega square minus p square, that whole square plus 4b square p square. So now from the equation, so we have so the solution of the equation x is equal to a the solution of this equation obviously x is equal to cos theta sin theta. Now from this part taken for the getting the solution we have already getting this. Okay, for the solution of this equation we write here that one x equal to omega square minus p square f cos pt whole divided over omega square minus p square plus b square p square. Is it clear? That whole square minus 2bd f cos pt by omega square minus p square whole square plus 4b square d square. Clear? So here is another part, another differential part is here. So we are chosen y is equal to a cos pt plus alpha is the solution. If x is equal to this one is the solution, obviously dx dt is become a minus a sin pt plus alpha, so minus a x. So obviously dx is equal to x, so ds is almost equal to minus, sorry, p, this one is p. So the solution omega square minus p square. So this part is already chosen as a r dash cos alpha, r dash cos alpha. So r dash cos alpha cos pt, and this part, another this part we have chosen already r dash sin alpha, and this part is become sin pt. D is become sin pt. Clear? Then the solution is equal r dash cos pt minus alpha, r cos x is equal to r dash pt. This is the solution of the force vibration. Next day we try to find out the different case and the energy of the force vibration. Thank you.